Hello iPaaS developers. So in this video, we are going to see the file-based integration pattern. So every iPaaS developer need to understand this file-based integration pattern. So we will see what is the concept and what is the flow and use cases. File-based integration pattern is a common enterprise integration pattern, which is used in old ESP products, middleware products, and in modern iPaaS tools as well. In this pattern, systems exchange the data using files instead of direct API calls or from databases. So data is exchanged between the systems via files. Files are placed in the source system and picked up by the iPaaS platform or middleware tool. Then it's processed by this middleware product or iPaaS tool. Then it is archived for the backup purposes. This pattern is widely used in legacy and batch-based systems. So the file may be having less volume of data or it may have the large volume of data. So how the file-based integrations works? The source system generates the file. It may be any format, CSV, XML, JSON, or text format. In modern systems, we may have this Excel, PDF, any kind of files the source system may place in the folder. So that folder may be shared location within the network, or it may be FTP server or SFTP server over internet, or it may shared via SMP protocol, or it may placed into the cloud storage. In modern iPaaS world, it may be used cloud storage. So this integration layer monitor those locations. So in old ESP product, it may be in local folder in the network, or it may be in the same server where this middleware server is running, or it may be SFTP server or FTP server. So it will monitor that particular location, and whenever the file plays, then it will get the file and process. And after that, it will send to the target system. This is the file-based integration flow. As I mentioned, what are the common file location? So it may be local file system within the network, or it may be FTP or SFTP server over internet. Within the network also, there is a protocol called SMB. So they share the file over this protocol. If it is in internet, and if they are going with the cloud providers, different cloud providers available. So based on the cloud provider, they may choose any storage, cloud storages. If it is Amazon, it's a Amazon S3 bucket. For Azure, it may be blob storage. For Google, they may go for Google Cloud Storage. The processing steps involve the polling. So in each product, this polling name may be different. It may be poll or listener or file watcher. So which will keep on listening that particular folder. And we can add the validation of the file name and format. So we can give the file extensions or file name. We can add those steps in our job. After getting the file, if you need to transform that file into another format, So those logic we can implement in the integration flow. And if you want to add any other business processing, so validating data from the file before processing, before transforming, so those kind of steps also we can add. Then last one is archiving or error handling. So if the file is successfully processed, then you can move to the archive folder. If there is any error happen while processing, then we can move to the error folder. What are the advantages of this uh, approach? It's very simple and easy to implement, and it loose coupling between the systems. It will work well with legacy applications. So in existing ESP product within the network, they can connect with any system, shared location, and they can take the data from source and target. In modern iPaaS world, it will work with the cloud storages as well. So you can connect with any cloud storage and read the data. So you can listen that storage and get the data as well. And it's file-based integration, so it's suitable for the large batch data transfers. So if you want to load the large volume of data from one system to another system, or moving from one system to another system, the large volume of files, we can use this approach. The limitations in this approach is it's not real time. So the file listener or file poller is configured with the time interval. It is called as near real time. So based on the polling interval, it will listen that particular folder. So it will gives the latency depending upon this polling interval. Then error handling in this approach is little complex because when we are processing large volume of data, so in between if there is any error happen, then you need to reprocess the whole file again. Then file management and cleanup required. So this is when we are going with the approach. Once you successfully processed, you are moving to archive folder. When you are successfully, if there is any failure, then you are moving to error folder. So in that cases, the files are filed up in those folders. So we need to clean up those folders periodically. Otherwise, it will occupy more memory. So it will occupy more storage. That action required in this approach. So these are all the different use cases, as we mentioned. So for daily batch data processing, we can go for this file-based approach. Data exchange between legacy systems, payroll and billing, file transfer, moving file between different cloud storage, data transformation between different file formats. If the source file is in XML, if you want to transform into JSON, so we can go for these approaches. We can use for this banking and financial batch integrations. Batch integrations, we can go for these file-based approaches. So this file-based integration is reliable and widely used. It's best for batch and legacy integrations. Still, it's relevant in modern iPaaS and cloud native systems. Combined with the APIs and messaging patterns. Suppose if you are getting file and you need to call some other API to push the data or get the data and send to the target system. So we can combine the API calls in this approach as well. That's all about the file-based integration. Thank you for watching this video. You can like and share your comments. If you want more videos like this, then you can subscribe our channel. Thank you.